Electrolyte is a substance that when you dissolve this substance in water or in solid, okay, in most cases in our territory, we use water as a solid. Okay, when you dissolve this substance in water, the solution can conduct electricity. That's the phenomenon. Okay, then
we have both dinosaur now.
the other concept is called the known electrolyte. Obviously, when you dissolve it in water, it cannot conduct electricity. Okay, I can show you a picture from the laboratory. This picture concerns water. Okay, then you dissolve something which is types of solute and so-called electrolyte or non-electrolyte. Anyway, we have done that and dissolved in the water and forming a solution. Then you have two wires and insert in this solution and see whether the electricity can be conducted. If so, the light should work, and otherwise you should have no light work. So in this case, because this is the solute dissolved in the water, should be no electrolyte because I don't see anything that works here. And this is another example. I dissolve and a similar other substance which is considered as electrolyte. So when I switch the electricity, you will see conduction. Okay, so we call this type of substance electrolyte. Sometimes you may compare the intensity of conductivity. See, I have the third one and similar things, but if I switch on the current, you see it is conductive, but it's not so good as compared to this one. So this type of electrolyte is normally called weak electrolyte, and this one is called relative to the weak strong electrolyte. So basically, the solute can be classified as two types. One is electrolyte, the other is called non-electrolyte. Right? And within the electrolyte, the conductivity is very good, and that's called the strong electrolyte. Otherwise, it's called the weak electrolyte. So both we were talking about are from the solute, right? And in this case, we assume the solvent is water. So I just summarize, and this is a comparison. So you have electrolyte, you have no electrolyte. So the electrolyte, the conductivity, if it is very good because it's strong electrolyte. Otherwise, that's weak electrolyte. Okay. For no electrolyte, absolutely you wouldn't be able to see the current. Okay. So no conductor. This is the second concept concerning the electrolyte and no electrolyte. One point I just mentioned here, which our textbook doesn't cover. Okay, to decide to decide a substance is an electrolyte or no electrolyte, normally, and we just determine whether the conductivity is good or not. So dissolving in water is not the single way to do so. You have a second way is when you melt the substance. If it is conductive, it's still considered an electrolyte. But the textbook never mentioned that. That's why I just mentioned for those you know chemistry very well. And so there is an additional way to test whether a substance is electrolyte or not. So here is something you should think about regarding the conduct electricity in the solution. Okay, what's the mechanism of the conducting? Actually, that comes the ions. Okay, either positive or negative. The nature for those electrolytes is when the electrolyte dissolves in water, and it will release some cations or anions, either of them. Okay, if a substance can dissociate such kind of particle, you have conductivity, no problem. So for strong electrolyte, normally you will 100% dissociate. This is example, you have a sodium chloride. When you dissolve sodium chloride into the water, this is the physical process. However, acted by the polar water molecule, and those sodium plus and chloride minus will be separated from the crystal. So they are moving freely and surrounded by the water molecule. Those can carry the electric charge for you in a certain way. Okay? Such things is called strong electrolyte. Sometimes your compound or your substance cannot 100% dissociate, release to the ions. So just a partial. I have an example is the vinegar, is the acetic acid, which is acid but it's the organic acid. The dissociation capability is very weak, but it does. Okay. In other words, when you have, for example, you have 100 molecules and exists in the water solution, probably have 5 or less than 5 molecules dissociate into the acid T, which is considered as anion, a plus, hydrogen plus, which is a proton. Okay, that's a cation. All the other 95 or more than 95 molecules do not dissociate. They still and keep in the form of a neutral molecule. In that case, you still see some ions which can help you to carry the electricity charge, but major of them cannot. That's why this kind of substance is called a weak electrolyte. So, as I mentioned earlier, the driving force is the polar water molecule. Okay, so this is a reversible and simple. So that tells you don't consider this direction only, and you should also consider the reverse direction. Means some of them may be recombined and back to the neutral molecule. So this is called a reversible reaction once you see such kind of the symbol. Okay. Again, such reaction will occur in both directions. So, therefore, the acetic acid is considered as a weak electrolyte because the ionization in water is incomplete. Ionization means you have water molecule. The water molecule can surround and those your solution molecule. Then drag until and break the chemical bond of your original molecule and forming two ions, positive and plus, separate. And the water molecule, of course, always surrounding each of them and moving freely in the solution. So that's called the ionization process. So this is a cartoon and showing you how it happens. And the red one, the red green one, and represent the water molecule. I have a lot of water molecule because this is in water solution. The solvent should be a large amount of components. Okay, so the water molecule itself is considered as a polar molecule, and we will study that shortly because of the geometry of the water molecule is not so symmetric. Well, it is symmetric, but the center of positive center and the negative center never overlap. That's why in the chapter 10 or chapter 11, you will learn so-called the dipole moment. Okay, for water molecule, you will see some dipole moment.